Bill Nye has just revealed some shocking truths from the depths of space that could turn our understanding of the universe on its head. The James Webb Space Telescope has captured images from over 13 billion years ago, exposing startling secrets of the cosmos. What if these ancient lights hold the key to mysteries we've never imagined? What hidden dangers could these new glimpses into the cosmos be showing us? Let's investigate these revelations and explore the potential impacts on our knowledge of the universe. The universe 13 billion years ago. The James Webb Space Telescope is making groundbreaking discoveries about distant worlds, galaxies, and other space phenomena. It's not just an impressive scientific tool, it's also seen as a worthy successor to the Hubble Space Telescope. But which images from the James Webb Space Telescope are shaking up our old ideas, and what does Bill Nye think about all this? Let's take a closer look. Creating the James Webb Space Telescope was a massive effort by NASA's scientists and engineers, and it successfully launched on Christmas Day in 2021. The telescope's deployment over the following months went off without a hitch. By late June 2022 it was fully operational, and researchers began identifying thousands of new galaxies. Some of these galaxies are older and farther away than any we've seen before. Some might have formed over 150 million years earlier than the oldest galaxies Hubble found. But the telescope does more than just find distant galaxies. It can also collect light from cosmic objects like exoplanets and young stars, helping us learn about their makeup and movements through space. Bill Nye explains that this data is beginning to show us detailed information about the atmospheres of planets hundreds of light years away, giving us clues about what they might be like. This breakthrough is deepening our understanding of the universe and could change how we think about the possibility of life beyond Earth. Yet this isn't even the most surprising part. One of the most well-known images taken by the Hubble Space Telescope is the Pillars of Creation in the Eagle Nebula. These stunning clouds were visible, but what was happening inside them remained a mystery. Now with the Webb telescope's infrared imaging, we can finally see inside, revealing many protostars. These are huge clusters of dust and gas much larger than our solar system, and they appear as small red dots against the dark background of the pillars. These dots are actually young stars just starting their lives. These newborn stars in the images haven't yet begun to burn hydrogen, as Bill Nye explains. As they gather more material, their centers become denser. Eventually the density gets high enough to start hydrogen burning, which raises their temperature by about 2 million degrees Celsius. In these images, different colors represent the infrared wavelengths we can't normally see. For example, what we see as blue in the image would actually look red to the human eye. The colors change based on the level of radiation, with the red areas where the protostars are emitting radiation at a wavelength about 6 times longer than what our eyes can detect. But that's not the only amazing thing about this image. The Webb telescope isn't just capturing beautiful pictures, it's also helping us understand how stars like our Sun might have formed. The discovery of planets outside our solar system, or exoplanets, started in the 1990s, and now we know of more than 3,000. Most of these planets have been found indirectly by noticing the slight dimming when they pass in front of their stars. However, the Webb telescope is changing this by directly capturing images of these distant worlds, giving us new insights into the universe beyond our solar system. Let's explore how new tools are opening up the far corners of space. HIP 65426b through advanced telescopic lenses. In September of last year, scientists took a clear picture of an exoplanet named HIP 65426b, first discovered in 2017. To get a good look at the planet, they used advanced telescopes to block out the bright light from the star it orbits. With the help of special cameras and filters, they managed to capture the planet, which is located 100 times farther from its star than Earth is from the Sun. This planet is a massive gas giant 12 times bigger than Jupiter in the vastness of space. Even though the phantom galaxy is mostly hidden, it still shines brightly, especially when viewed through the Webb telescope's infrared capabilities. The galaxy, with its grand spiral shape and long arms of stars, glows from the center, creating a stunning view. The Hubble telescope has also captured detailed images of this galaxy, also known as M74, but the latest images from the Webb telescope show even more detail, revealing patterns of dust and gas that emit heat. These patterns glow in bright electric blue from the core, lighting up the star-forming regions along the spiral arms in a way we've never seen before. The amazing images from both the Hubble and Webb telescopes are thanks to Researchers at the European Space Agency who are part of an international project called FNGS. This project uses different telescopes to take infrared images of 19 nearby galaxies that are actively forming stars. The clear detailed images from Webb help astronomers find exactly where stars are forming, figure out how old and how big star clusters are, and learn more about the dust between stars. But there was something even more interesting. In July of last year, a photograph of a star called Wolf-Rayet showed a unique pattern around it known as Webb's recognizable diffraction pattern. This pattern looks like a series of ripples or rings. Wolf-Rayet stars are massive and near the end of their lives, and they release a lot of hydrogen into space. The ring shapes around this star called WR140 happen because of its interaction with a smaller companion star, creating a kind of dance in space. This fascinating sight is just one of the ways Webb is helping us explore distant galaxies and uncover cosmic phenomena that continue to expand our understanding of the universe. The James Webb Space Telescope recently made an incredible discovery by identifying 4 of the oldest galaxies we've ever seen. These galaxies are being observed as they were 13.4 billion years ago, which means we're looking back to a time when the universe was just 350 million years old, only 2% of its current age. Each of these ancient and distant galaxies shares traits with many other galaxies that Webb has found. Scientists used advanced methods from the James Webb Space Telescope Advanced Deep Extragalactic Survey to study these galaxies. They used the telescope's near-infrared spectrograph to understand how quickly these galaxies are moving away from us. This movement stretches the light they emit into longer, redder wavelengths, a process called redshift. The highest redshift measured among these galaxies was an incredible 13.2, indicating distances and ages much greater than what was expected before the launch of the Webb telescope. For the first time, we now have the ability to not only find these distant galaxies but also to confirm their great distances through spectral analysis. But that's not the only exciting thing Webb has been up to. In another part of the sky, Webb turned its focus to a planet orbiting a star in the constellation Virgo. This planet, named WASPN 39b, is 700 light-years away, which is relatively close in cosmic terms, about 8 times the distance between Mercury and the Sun. Even though it's close, WASP 39b is a harsh place. It's similar in size to Saturn, but is scorching hot because it orbits very close to its star. Its thick atmosphere is filled with clouds made of sulfur compounds and silicates like sulfur dioxide. Now we turn from distant galaxies to the mysteries of alien atmospheres. A new perspective on distant worlds. For the first time, using Webb's main camera and 2 of its spectrographs, researchers detected carbon dioxide in the atmosphere of WASP 39b. This discovery opens up new opportunities to understand the atmospheres of planets far beyond our solar system. It's a big step forward in our quest to learn more about the conditions and makeup of distant worlds. This combination of cosmic discovery and planetary research highlights the telescope's unique abilities, helping us learn more about both the early universe and the complex systems of distant planets. But there's more. These findings are just the beginning of what Webb is capable of discovering. The deeper we look, the more we realize how much there is yet to uncover. Scientists were able to make educated guesses about the planet's origins and how it evolved. They think that the planet was formed much farther away from its star and was brought together by the merging of smaller space objects. This idea is backed by the fact that there is more oxygen than carbon in its atmosphere. Meanwhile, Saturn's moon Titan stands out as a unique and fascinating world. On Titan, rivers, lakes, and seas are made not of water but of liquid methane and ethane, while the ground is composed of water ice. Methane clouds, which are not found on any other moon, cover Titan, making it the only moon in our solar system with a thick atmosphere. In November, scientists using the Webb telescope captured images of these methane clouds on Titan. This was a significant event, as highlighted in a NASA statement. The Webb telescope successfully captured images of 2 separate clouds, including one over Kraken Mare, Titan's largest sea. This discovery was so intriguing that it led the team to collaborate with the Keck Observatory in Hawaii for additional observations of Titan just 2 days later. The observations from Keck revealed that the cloud over Kraken Mare had changed its shape, hinting at movement or the formation of a new cloud in the same area. The research team is eager to use this data to further explore Titan's atmosphere and map its hazy appearance with hopes of detecting new gases. The Southern Ring Nebula, once thought to be just an ordinary white dwarf, a dying star shedding its outer layers, turned out to be more complex than initially believed. Recent studies have challenged the assumption that only the main white dwarf in the center of this nebula was contributing to its shape and growth. Instead, astronomers now think that there's another companion star in the background influencing the nebula's development. This changes how we view and understand these beautiful cosmic structures, highlighting the vastness and complexity of the universe beyond what we once knew.